All right, 4.1 part 2, a radian measure. The definition of a radian is 1 radian is the measure of the central angle that intercepts an arc S equal in length to the radius. So we have our radius, and we're saying that the arc, this arc, is the same length as the radius. So picture wrapping that radius around, and then whatever angle this makes, this angle is equal to 1 radian. Theta is equal to S divided by R in radians. And so if you were to wrap your radius all the way around the circle, you would see that this is approximately 3.14 or pi. And if you keep wrapping, how many radius would fit around the outside of the circle would be exactly 2 pi radius around the circle. So that's where radian comes from. So our 2 pi is equal to 360 degrees. Pi over 2 is equal to 90 degrees. Pi is equal to 180 degrees. And 3 pi over 2 is equal to 270 degrees. So now we have to figure out how are we going to draw these angles if we know them in radians instead of degrees, because we don't want to be converting them every time. And sometimes students think that's the easiest way, just to convert them into degrees. I think it's better to learn a radian and practice in radians. So we're going to think about pi over 4. Well, this is 0. This is pi over 2. 1/2 of a pi is bigger than 1/4 of a pi. And so pi over 4 would be that angle in quadrant 1. Negative 11 pi over 6. Okay, so it's negative, so we know that's going to be rotating in the clockwise direction. And this, we can compare fractions using common denominators. So we could say that this is 6 pi over 6. And so we have our initial side. We're going to rotate counterclockwise. This is 6 pi over 6. We're trying to get to 11 pi over 6. Get a common denominator here. I would multiply the top and bottom by 3. So I'm sorry. I need to have this, because rather than it being pi over 2, it's really 3 pi over 2 because I'm rotating the opposite direction. So if this is 3 pi over 2, then this would be negative 9 pi over 6 if I got a common denominator. So 11 pi over 6 is bigger than that. So it's going to be in quadrant 1. You can also think of 11 is almost 12, and 12 pi over 6 would be 2 pi. So we have the first one is quadrant 1. Second one is also quadrant 1. 7 pi over 3. Well, 7 pi over 3 is bigger than 2 pi, right? Because 6 pi over 3 would be 2 pi. So this angle is 2 pi and 1/3. Which would actually be here. So this would also be quadrant 1. So the first 3 are all quadrant 1. The next one is negative pi over 6. Negative pi over 6 is less than pi over 2. We're rotating in the opposite direction because it's negative. And so we get our angle in the 4th quadrant. Oops. 7 pi over 4 is almost 8 pi over 4, so it's almost 2 pi. So 7 pi over 4 is going to be in the 4th quadrant, not quite past the 4th quadrant. So we have our initial side. It's positive, so we rotate counterclockwise, and we get it in the 4th quadrant. 2 pi over 3. Okay, 2 pi over 3, we're going to start by comparing that with 1/2. Is 2/3 bigger or smaller than 1/2? Well, if you're having trouble with that, get a common denominator. So I could write this as 3 pi over 6, And I could write this one as 4 pi over 6, and it looks like, yep, this one is bigger, so this one is going to be in quadrant 2. Oops. So for these, you're going to practice sketching the angle in standard position. And I'm just going to do the ones in radians. So to sketch this, 2 pi over 3 is bigger than pi over 2. And so I'm going to sketch it with the terminal side. You want to show the angle of rotation to show that it's positive and that it's going to be rotating clockwise or counterclockwise. Negative pi over 6, we have our initial side, our terminal side, and it's going to be rotating counterclockwise. 5 pi over 3, and it's negative. 5 pi over 3 is very close to 2 pi, so it's almost a whole rotation of a circle. We're rotating counterclockwise, so it's going to be in quadrant 1. Again, we can find the two coterminal angles, but this time we're going to be adding or subtracting 2 pi. And you can get a common denominator to do that. So we're going to add 2 pi, but if I add 2 pi with a denominator of 3, I'm really adding 6 pi over 3. And so 7 pi over 3 is a coterminal angle, but I could also subtract and get negative 5 pi over 3. Same thing with negative 3 pi over 5. I'm going to get a common denominator. And so instead of adding 2 pi, I'm going to be adding 10 pi over 5. And I'll also subtract it. So I get 7 pi over 5 and negative 13 pi over 5. 7 pi over 3, I can add 6 pi over 3. Because 6 pi over 3 is the same as 2 pi. Get a common denominator. I get 13 pi over 3, and then if I subtract, I get pi over 3, but that's not negative, so I'm going to subtract again. Pi over 3 minus 6 pi over 3 is 5 pi, or negative 5 pi over 3. And those would all be coterminal angles. Each angle has an infinite number of coterminal angles. Supplementary angles now in radians are two angles that have a sum of pi to pi radians. And complementary angles are angles that have a sum of pi over 2. It says find the complement and the supplement if possible. So I'm going to do pi minus 2 pi over 3. And we're going to get a common denominator, which would be 3 pi over 3. And we get pi over 3. This would be the supplement. To find the complement, I can do pi over 2 minus pi over 8. And I'm going to get a common denominator by multiplying the top and bottom by 4. The complement would be 3 pi over 8. The supplement would be pi minus pi over 8, or 8 pi over 8 minus pi over 8, which is 7 pi over 8. So you can convert angles by using the fact that 360 degrees is equal to 2 pi radians. Or, if you divide both sides by 2, 180 degrees is equal to pi radians. So 1 degree would be equal to pi over 180 radians. And 1 radian would be equal to 180 divided by pi. So now we can go ahead and convert degrees to radians. But again, I don't want you to rely on this. To convert from degrees to radians, multiply by pi over 180, and to convert from radians to degrees, multiply by 180 over pi. It says without a calculator. You can use a calculator, but leave your answer as an exact. So we're going to multiply by pi over 180 to convert from degrees to radians. So the first thing I'm going to do is look for common divisors. So I'm just going to divide the top and bottom by 5, and I get 45 pi over 36. And then I can divide by 9, and I get 5 over 4. And then it doesn't always say radians, but you can assume if it doesn't have a degree symbol that it is in radians. This one I can divide by 10, get rid of the zeros. I can divide by 2, and if I divide by 2 I get 24 pi over 9. I can divide by 3 and I get 8 pi over 3. This one, because it's negative, you're going to have a negative radian, 2. So I'm going to divide by 5. I get 27 pi, negative 27 pi over 36. Divide by 9. I get negative 3 pi over 4. And then we can go the other way by multiplying by 180 over pi. The pi's cancel. I'm left with negative 180 divided by 3, which is negative 60 degrees. Here I'm going to multiply by 180 divided by pi. Pi's cancel. I'm going to be left with, be left with 9 times 90, which is 810 degrees. 3 radians is going to be 3 times 180 divided by pi. For this one, we do need our calculator. And I get 171.89 degrees.